Okay, now we're going to do, again, what I consider one of the most important topics that I'm going to teach you this entire semester, dimensional analysis. Before I do that, though, I did miss recording in the last section the difference between accuracy and precision, and I do want to hit on that real quickly. The difference between accuracy and precision: accuracy is how close you get to the actual or accepted target, and precision is how consistent you are. And usually when I teach accuracy and precision, if you're anywhere close to my age or have any kind of age on you, if you're not fresh out of high school, most of you know who Shaquille O'Neal is. And I'm old enough that I can remember when Shaquille O'Neal was very first drafted into the Orlando Magic. That's quite a long time ago. I do actually remember sitting and watching that, the draft, with my husband. I'm not a huge basketball fan, but I do remember when he was drafted. And I remember hearing the commentators talking about the money that they were going to spend at the Orlando. Not only did they spend the money to draft him, but they hired a coach for nothing else than to work on Shaq with his free throws, because he was a great ball player on every issue except for his free throws. And the coach that they were going to hire, they were going to pay him more for coaching him just for a little while with his free throws than I made in a year of teaching. And I remember thinking, man, I'm in the wrong business. But he was very consistent with his free throws. He was just lousy at his free throws. He had a free throw percentage of like 33% or something like that. But his free throws would all hit the front of the rim, and they would bounce off. So he was very precise because he hit the same spot over and over, but he was not very accurate. He could not hit that target. So accuracy is how well you hit your target or your accepted value. Precision is how often do you get the same value over and over again. And that does have everything to do with how good is your measuring equipment. Do you have a good ruler? Do you have a good graduated cylinder? Do you have good tools? Because if you have good tools, then you should be able to get very good, accurate readings over and over again, very consistently, if you have good techniques. So there you go, accuracy and precision. Now let's get on into conversion factors and dimensional analysis. I don't usually call it dimensional analysis. I usually call it unit analysis for two reasons. Number one, unit analysis is much easier to spell and to say than dimensional analysis. And also, unit analysis gives an idea, more of an idea, I think, of what you're doing. Unit analysis or dimensional analysis is using units to solve your problems. And that's exactly what you're doing in dimensional analysis. You're using your units. So I'm going to probably slip into saying unit analysis more than dimensional analysis, but that's what it is. It's using units to solve problems. And you do it all the time. You just don't even think about it. We do it a lot. Every time you say to yourself, I need to change these dollars into quarters, or I need to change, days into weeks, or weeks into days, or, whatever. We do that in our heads all the time. But this is a very important skill in chemistry. You're going to use it when we're going to change moles into grams. We're just going to use it a whole lot in this semester. So you must get proficient at it. First thing you need to know is what a conversion factor is. A conversion factor is a ratio or a fraction. Ratios are just fractions. That's all they are, so don't be afraid of that word. That is equal. Two numbers that are equal to each other. And we can write them in any way we choose to. In this case, they've written 1 inch is equal to 2.54 centimeters. This is getting us from an English unit to a metric unit, which is fine. And we can switch back and forth into English, metric, and by the way, I am on page 22 in your text. is where this is coming from, but we use them all the time. I could tell you that there are 7 days in a week, and then we could do an easier conversion if that makes you happy. But that's exactly where we're going here. Now, does it matter which one of these, if we're going to write this as a fraction so that we can solve a problem with it, does it matter which one of these two we put on top? Absolutely, it does not. Does it matter if we say that there are 4 quarters in a dollar or 60 minutes in an hour? Does it matter which one of those two we put on top and which one we put on the bottom? No. It matters only if we're saying, well, do we want to change minutes to hours or hours to minutes? Now it matters. Now it matters. So here's where we're going to go. And what you need to know about is how do you go about using a conversion factor to solve a problem. Now, since a conversion factor is an equal quantity, when you write it as a fraction, it's like saying 3 over 3 or 5 over 5. Isn't 3 over 3 1? Sure it is. Does it matter if I write it as 3 over 3, or can I say 2 plus 1 over 3? Do I have to say, if I'm writing the number 1, and we all agree, I hope we all agree, that any number written over itself is 1. 5 over 5 is 1. 10 over 10 is 1. 50 over 50 is 1. 60 minutes over 1 hour is 1, because these two things are equal to each other. So they are 1. So what does it matter if I write 3 over 3 or if I write 5 minus 2 over 2 plus 1? Isn't this equal to 3? Yes. Isn't this also equal to 3? Yes. So isn't this also equal to 1? Sure, it is. So do not let it confuse you, the fact that they may not look the exact same. This is the same exact thing as 1 inch. 2.54 centimeters is the exact same thing as 1 inch. Therefore, I'm writing two equal things over itself, so it equals 1. It does not change the value. It's like saying 4 quarters is the same thing as $1. So I am not changing the value. All right. Therefore, we can use them to solve problems using unit analysis or dimensional analysis. And I'm going to show you how I like for my students to show their work with this. And it's not exactly written in this text, but I think it's extremely helpful. So I'm going to exit out of drawing mode here, and I may even do a different video. But here's how I like for my students to do it. I like for my students to say, okay, what's my given? What am I looking for? What's my unknown, in other words? What conversion factors or confacts do I know between my given and my unknown? And then you're going to solve, and you always solve by starting with the given. So if we were to work a practice problem, for example, if we were to work the sample problem that's on page 24 of your text, where it says the Food and Drug Administration recommends sodium intake be 2,400 milligrams per day. What is this mass in pounds? So what are we given? We're given here that our sodium intake should be 2,400 milligrams per day. Now, please, let's pay attention to our sig figs also. How many sig figs is that? Get that in your brain. Okay, I want you to think about that. Now, it asks us, what is this mass in pounds? So what are we being asked to find? We're being asked to find pounds. And now let's talk about our confactors. what do we know about pounds? It gives it to us, which I'm not going to be nice to you. If you were sitting in my classroom, that would be one I would tell you to know. There's some that you should just know. You should know that there's 2.54 centimeters in an inch, and you should also know that there are 454 grams in a pound. Those are some that I would expect you to know. Like for a midterm or a final, those are some I would want you to know. 454 grams is 1 pound. And what about milligrams to grams? Do you know that one? I would hope so. I would hope that you would know that there are 1,000 milligrams in 1 gram. Okay? Now, here's the questions that you should be able to ask yourself and that you should always be able to ask. You should be able to say, okay, do I have, let me get a highlighter. Do I have a compactor that's got milligrams in it? And do I also have a compactor that's got my unknown of pounds in it? If you can say yes to both of those, then you know you're ready to solve. If you can't say yes to both of those, then you need to find more compactors. That's the key. That's why I love dimensional analysis, because you can know with surety, hey, I've got this. And when you solve, you're always going to start with your given. So I'm going to start with my given, 2,400 milligrams. And you never want to put anything underneath here unless it's also in your given. All right? So I've got milligrams in this top. How do I get rid of something that's in the numerator? I need to put it in the denominator. Where do I get these numbers? From my compactors. You never want to get anything except from your compactors. So I have 1,000 milligrams, and it goes in the denominator. 1,000 milligrams, and where's its partner? Right here. So there's my 1 gram. So there's my milligrams, and it's going to cancel with that milligram. Now I have gram, and I use that one, so I'm going to cross it out. Now I have grams in the top. It's not what I want. It's not my unknown, so I'm not finished, and I know that I'm not finished. So where am I going to get? I know that now I need another conversion factor. I need another fraction so that I can get rid of that grams. Grams is on top. I need to get rid of it, so I need to put it on the bottom. Where do I get things to cross out? From my conversion factors, and it just so happens I have another conversion factor that's got grams in it. So I know this 454 grams goes in the denominator, and that 1 pound goes in the numerator. And now this gram is going to cancel out with that gram. And so now that lets me know that I am doing this correctly because I'm able to cancel out my units. Now when I put this in my calculator, I'm going to put in 2,400 in my calculator. This is my keystrokes on my calculator. 2,400 times 1 divided by 1,000 times this 1 divided by 454, then enter. That's exactly how I'm going to put it in my calculator. One more time. 2,400 times 1 divided by this 1,000 times this 1 divided by this 454, enter. And that's exactly how I would enter it in my calculator. In fact, I've got a calculator right here. Let's kind of do that together. 2,400 times this 1 divided by 1,000 times this 1. Of course, you know that doesn't change anything. And then divided by 454. And that gets 0.005. 0.005. Actually, it's 0.005. Is what I got. All right, and that, but how many sig figs am I allowed to have? How many sig figs does this given have? Because that's how many you are allowed in your answer. Since it only has 2 sig figs, then that's all I'm allowed in my answer. So that's going to round it to 0.0053. Or I can write that in scientific notation as 5.3 times 10 to the negative 3. So that is going to be my answer, 0.0053. All right, I'm going to give you lots of those to practice. In fact, I'm going to put a website on there. It's not going to be for a grade necessarily, but it's a website that I found that's called thatquiz.org. It has lots of these for you to practice because it's that important. So this is a very short video that you can watch several times. but it is so important. And I'm going to give you many of these to practice because it's so important. Have a good day.